When researchers tested fuel from everyday gas stations across the US, they weren't expecting disaster. But one test uncovered a silent engine killer, fuel so low in quality, it was choking modern engines from the inside out. Engines seized, sensors failed, pistons melted, all from fuel that looked perfectly normal at the pump. And the worst part? Drivers never saw it coming. Your cheap fill-up might be slowly destroying your engine, and it's happening across the country. The Georgia highway breakdown, a nightmare starts at the pump. It began with a series of calls that sounded almost unreal. One after another, drivers stranded on I-95 in southeast Georgia, cars dead on the shoulder, engines silent. Nearly 24 motorists reported the same experience. They filled up with fuel, pulled onto the highway, and within a few miles their vehicles began to shake, lose power, and stall. Dashboard lights blinked warnings. Check engine lights glowed. Some cars coasted to a stop before the engine even turned over again. Tow trucks lined highways. Repair shops in Savannah were flooded with calls. The common factor wasn't driving habits or vehicle age. It was where they refueled. Mechanics who inspected the engines noticed an unusual pattern: heavy carbon buildup in the combustion chambers and around injectors, more than would be expected even in worn engines. Fuel filters were choked with dark, gritty residue. Fuel pumps were overheating. One technician described it this way: it was like these cars had been fed mud instead of gasoline. Drivers told a consistent story. They'd stopped at cheap, local gas stations in small towns along the interstate, thinking they were saving a few cents per gallon. Few had ever seen issues before, and none expected that filling the tank could lead to engine failure so quickly. What made it stand out was not just the scale, dozens of cars broke down in a short window, but the uniformity of symptoms across different makes and models. Hondas, Fords, Toyotas, vehicles with completely different designs were all failing in nearly the same way. At first glance, it seemed like an anomaly, a freak cluster of bad luck. But then similar breakdown reports started cropping up in neighboring states: South Carolina, Florida, even as far west as Alabama. The pattern was too consistent to ignore. Vehicles were failing shortly after fueling at certain stations. That raised a fundamental question. Why were identical systems suffering similar failures, triggered by fuel that looked normal at the pump? And that question pointed toward an uncomfortable truth. Not all gasoline is equal. It felt like my engine had been suffocating, like trying to breathe through a clogged straw, one driver said, capturing the desperation of loss of power on a busy highway. This wasn't random. It was fuel-related. And that realization would set the stage for a deeper investigation into what exactly drivers are putting into their tanks and how it can destroy engines. The fuel you don't see. What comes out of the nozzle matters. When most people fill up at a gas station, they assume that all gasoline is essentially the same, that regular unleaded in one town behaves just like regular unleaded in the next. But what drivers rarely see is what happens before the fuel reaches the pump. Gasoline starts its life as a refined mixture, but it isn't finished until it gets additives that determine how it actually behaves in an engine. At the fuel terminal, the large storage and distribution point between refinery and station, additive packages are mixed into the gasoline. These include detergents, stabilizers, anti-corrosion agents, and other chemicals designed to improve performance. But here's the catch. There's no single industry-wide standard for how strong these additives must be. The EPA's minimum requirements, set decades ago, were based on older engine technology from the 1990s. Today's engines, especially gasoline direct injection, GDY engines, are far more sensitive to deposit formation and carbon buildup. Modern engines can actually trap carbon in places older engines did not. In port-injected engines, the fuel sprayed over the intake valves help keep them cleaner. But in GDI engines, the fuel bypasses the valves entirely, meaning cleaning must come from additives. If the fuel has low detergent levels, the engine ends up pumping gas that doesn't clean itself. Tiny soot particles accumulate, valves gunk up, injectors clog, and over time the engine begins to lose power, stumble, and fail. One mechanic described the effect this way: It's like your engine is trying to breathe through a clogged straw. The fuel doesn't necessarily smell wrong, the pump doesn't register a problem. But in the combustion chamber, tiny deposits fuse together, impairing performance. Low detergent fuels allow these deposits to grow unchecked. Over thousands of miles, this buildup doesn't just reduce mileage, it can lead to complete engine failure. Worse, because the symptoms mimic other problems. Misfires, sensor faults, rough idle. Drivers and technicians can chase the wrong diagnosis unless they suspect fuel quality first. The bottom line, gasoline isn't just a commodity. What's added or not added matters. And the Georgia breakdowns made one thing obvious. The fuel that comes out of the nozzle can make or break an engine. Top-tier fuel, the higher standard you never heard of. Not all gasoline is created equal, even if the pump says regular, mid-grade, or premium. That's where top-tier fuel comes in. What most drivers don't know is that the EPA's standard for gasoline detergents is a bare minimum, set decades ago when engines were simpler. But modern engines, especially GDI and turbocharged models, demand much more detergent power to keep themselves clean. In response, a group of major automakers, BMW, Toyota, General Motors, Honda, and others, established what's known in the industry as top-tier gasoline. This certification isn't about octane, it's about detergent strength. Top-tier fuel must contain significantly higher levels of cleaning agents, roughly 2.5 times the amount required by law. Why does that matter? Because strong detergents actively prevent the kind of buildup that leads to clogged fuel injectors, sticky valves, and carbon fouling. Engines running top-tier fuel stay cleaner longer. They breathe better, they maintain performance and fuel economy, and crucially, they avoid the soot and deposits that lead to accelerated wear and early failure. So why don't all stations sell top-tier gasoline? The answer comes down to cost and profit. Detergent additives aren't cheap. Adding more detergents increases production costs by just a few pennies per gallon. But for a low-margin business like fuel retailing, those pennies matter. Many inexpensive brands choose the bare minimum detergent mix allowed by regulations to keep prices low, even if it means long-term damage to sophisticated engines. Real-world experience supports the science. Cars regularly fueled with top-tier stations show less carbon buildup, smoother performance, and fewer warranty claims. Some fleets intentionally use only top-tier fuel to protect their vehicles, understanding that prevention costs less than repair. And while marketing labels don't always make the difference obvious at the pump, the performance results do. For drivers, the takeaway is simple. Top-tier versus bare minimum gasoline isn't just branding, it's engine longevity insurance. Choosing cleaner fuel may cost a few cents more per gallon, but it can mean thousands saved in repairs down the road. The dirty dozen, the worst stations for your engine. Not all gas stations protect your engine, and some are quietly causing more harm than good. Across the U.S., mechanics are seeing repeated issues tied to fuel from well-known retailers that meet only minimum standards. Safeway gas stations often sell fuel with weak detergent packages. Cars, especially models like Honda Civics, arrive at shops with misfires, clogged filters, and heavy carbon buildup, all signs of poor fuel cleaning power. 7-Eleven, due to its franchise model, has inconsistent fuel quality. Some locations receive deliveries with water contamination or ethanol spikes, leading to corrosion and injector damage, especially in humid or rainy climates. Sam's Club moves fuel quickly, but high turnover churns sediment into cars. Mechanics describe finding coffee-like residue in fuel filters, signaling unfiltered particulates, accelerating engine wear. Circle K sees frequent phase separation, where water and ethanol separate in storage tanks. That mix rusts injectors and degrades pumps fast. Murphy USA at Walmart often shows ethanol levels above 15%, stressing engines not built for it. This leads to lean combustion, valve overheating, and piston edge damage. These stations may not break laws, but they meet only the bare minimum, and that's not enough. The damage they cause is real and costly. The truck stop. Truck stop trap. Premium look, budget results. Truck stops might look like the safest place to refuel, but behind the branding, the fuel often tells a different story. Stations like Speedway, Love's, AMO, and Pilot Flying J have been tied to recurring fuel quality issues that damage engines over time. Speedway's detergent levels are inconsistent. Some locations show elevated sulfur, which damages catalytic converters and increases emissions. Love's travel stops face issues with microbial growth in tanks, producing fuel-blocking slime that can clog filters at highway speeds. AMO, once respected, now suffers from inconsistent cleaning strength, meaning more engine deposits and shorter maintenance cycles. At Pilot Flying J, mechanics report unusually high particulate matter from their gasoline, with injectors failing early and engines showing carbon buildup even in low-mileage vehicles. Another red flag, the summer blend scam theory. Some stations sell winter blend fuel out of season to save costs. These blends evaporate quickly, reduce power, and leave carbon behind, hurting performance and fuel economy. For long-distance drivers, the risk is real. These truck stop fuels may look convenient and familiar, but under the hood, they can quietly shorten your engine's life. Don't assume big brands equal better gas. Sometimes they just mean bigger repair bills. Branding illusion, when marketing outruns reality. Big logos, flashy slogans, and racing partnerships can fool even experienced drivers. But the truth is, premium branding does not equal premium fuel. A shiny pump with bold imagery might be selling some of the weakest gas on the market. Sunoco Regular is a key example. It markets itself with NASCAR branding, yet mechanics find that vehicles fueled with it often suffer from low-speed pre-ignition, LSPI. That's a knock condition so severe it can crack pistons. Reports show that Sunoco's regular fuel lacks sufficient detergents, allowing carbon buildup on valves and injectors, especially in G-Doid-My engines. Symptoms appear early: rough idle, overheating, sensor faults, and engine hesitation. Many cars fueled with Sunoco experience performance decline within 20,000 to 30,000 miles. One mechanic summed it up: branding doesn't matter when the chemistry doesn't protect the motor. This is marketing over maintenance. A nice logo doesn't prevent injector failure. NASCAR decals won't stop carbon from suffocating your intake system. Drivers need to understand, high-octane claims are worthless without a strong additive package behind them. Don't buy the image, buy the protection. Choose fuel that's engineered to clean, not just advertised to impress. The ultimate engine destroyer: waste fuel blenders. Among the most dangerous threats to your engine isn't poor quality gasoline. It's fuel that was never meant for engines at all. Known in the industry as transmix, this waste fuel is a mix of solvents, sludge, and industrial byproducts illegally blended and sold as gasoline. Why? Because it's cheaper to sell it as fuel than to dispose of it as hazardous waste. Transmix isn't just bad gas, it's chemically unstable, contaminated, and destructive. In real cases, vehicles seized for inspection had fuel that smelled like paint thinner. Pistons had fused to engine blocks, catalytic converters melted, and fuel lines were corroded from within. One mechanic found oily sludge in a brand new vehicle's intake system after just one refill. These blends are often sold by unregulated distributors cutting corners. They mix waste oil with small amounts of gasoline to mask the odor, then offload it as discount fuel, often at pumps where fuel is 20 to 30 cents cheaper. Drivers are unknowingly filling up with what amounts to toxic chemical soup. This isn't just low detergent, it's engine poison. The damage is rapid, irreversible, and expensive. If gas seems too cheap, be careful. That low price might just be hiding a mechanic's worst nightmare. The big brand defense. Why some fuel actually protects engines. While some fuels damage engines and others actively protect them, thanks to advanced additive packages and strict quality control. Brands like Chevron, Shell, Exxon, and Costco consistently lead when it comes to keeping engines clean and running longer. Chevron with Techron uses a patented polyethyramine compound that breaks down carbon buildup on valves and injectors. It doesn't just prevent deposits, it cleans as you drive. Shell's nitrogen-enriched fuel forms a protective layer on metal surfaces, reducing the chance of carbon sticking in the first place, even under high stress. Exxon Synergy offers uniform detergent levels across all grades, so whether you're buying regular or premium, you're getting solid protection. Costco, despite being a warehouse store, delivers fresh fuel quickly due to high turnover, and their top-tier certification ensures the detergent levels meet strict standards. Drivers who use these fuels consistently report smoother idle, fewer misfires, and better long-term performance. Mechanics notice fewer carbon-related repairs in engines that run on high-quality fuel. The takeaway? Premium fuel isn't just about octane, it's about chemistry. Spending a few extra cents per gallon at a trusted station can prevent thousands in repairs and extend your vehicle's life significantly. The engine science you must understand. To understand why low-quality fuel destroys engines while good fuel protects them, you need to understand how modern engines actually work. Today's cars are very different from those built even 10 years ago, mainly because of gasoline direct injection, GDI. In older engines, fuel was sprayed over the intake valves, naturally washing away dirt and deposits. In GDI engines, fuel is injected directly into the combustion chamber, which improves efficiency and power, but removes that natural cleaning effect. That means fuel additives are now the only defense against carbon buildup. If detergents are weak or missing, carbon forms quickly on intake valves and injectors. Over time, engines lose power, idle roughly, hesitate under acceleration, and burn more fuel. This buildup doesn't announce itself loudly. It creeps in quietly, which is why it's often called a silent killer. High-quality fuel contains detergents designed to dissolve and carry away early deposits, like tiny cleaners working inside the engine. Without them, particles stick, layers form, and airflow slowly becomes restricted. Ethanol adds another problem. It attracts water. When water separates from ethanol in storage tanks, a process called phase separation, it leads to corrosion, poor combustion, and clogged injectors. In short, modern engines require clean fuel with strong detergents. When fuel fails to deliver that, even well-designed engines degrade faster than they should. This isn't theory, it's chemistry and physics happening every time your engine fires. The bigger picture, industry incentives and what it means for you. Across the fuel industry, there's a constant battle between profit and quality. Gas stations operate on thin margins, and one of the easiest ways to cut costs is by reducing additive packages. Additives cost only pennies per gallon, but they make a massive difference in engine protection. When stations choose the bare minimum, engines pay the price later. Automakers recognized this problem years ago. That's why they pushed for top-tier gasoline standards. Because EPA fuel requirements were written in the 1990s, long before modern engines became common. Today's engines need more protection, but fuel retailers are not required to meet those higher standards. This creates a dangerous incentive. Stations selling cheaper fuel can undercut competitors on price, while the long-term damage shows up after warranties expire. Many technicians believe this aligns too neatly with rising repair costs, though whether intentional or not, the pattern is real. Another key factor is the aging vehicle fleet. The average U.S. car is over 12 years old, making older engines even more vulnerable to low detergent, fuel, and ethanol-related corrosion. The takeaway is simple. Saving a few cents at the pump can cost thousands later. Fuel quality matters more than ever. Choose fuel smarter, not just cheaper. Not all gas is safe. Some fuels meet only the legal minimum, and that's not enough for today's engines. What you put in your tank matters more than ever. Don't save pennies to spend thousands later. Choose fuel that protects, not poisons, because your engine deserves more than the cheapest option.